Hi, I am Dr. Sinjan. In this part, I am going to talk about corneal imaging in regard with keratoconus and ectatic corneal disorders. Of course, there are much more details about reading and interpreting corneal imaging. This can be found in my book, Corneal Topography in Clinical Practice, the second edition that was published by JB Brothers. But in this course, I'm going to present the details that are sufficient for classification and management modalities. Good luck.
Section 1, Part 1, Diagnostic Tools. In the last video, I mentioned and discussed the clinical findings and corneal biomechanics. And in this video, I will talk about corneal imaging. Corneal imaging. There are three different types of corneal imaging devices. The first one is topography. After that came the tomography, which is based on slit scanning such as Orbiscan or on Scheimpflug image such as the Pentacam, Cyrus, or the Galilei. And finally, we have the OCT, the anterior OCT. By the anterior OCT, we can obtain a full thickness map or a pachymetry map. The pachymetry map taken by the OCT can show us the focal thinning, and the most important or the most advanced technology in this regard is the epithelial layer mapping. As we see here in this picture, we can see the focal thinning of the epithelium over the apex of the cone, and we can see the focal thickening of the epithelium over the flat area of the cornea. By the epithelial mapping, we can detect very early cases of keratoconus even before focal thinning in full thickness pachymetry. Now, what's the difference between topography and tomography? The topography, as I mentioned in the last video, is based on a Placido disc, which gives us only information only from the anterior surface of the cornea. And by the topography, the curvature map is calculated, while the curvature map is measured, and from the curvature map, the elevation map is calculated. Opposite to this, the tomography, which is based on the Scheimpflug image. In the Scheimpflug image, the elevation map is measured, and from the elevation map, the curvature map is calculated. In addition, by the tomographer, we can obtain a wide range of maps, such as the elevation maps, curvature maps, pachymetry maps, power maps of the cornea, and more others. While the topography can give us only two kinds of anterior curvature maps, which are the anterior sagittal and the anterior tangential maps. Now, the question is what to look at and what to look for on tomography. We have to look at shape and parameters. We have main maps: the anterior sagittal curvature map, the anterior elevation map, the posterior elevation map, and the pachymetry map. Starting with the curvature map. On the curvature map, the normal pattern is the symmetric bow tie, where we have inferior segment and superior segment. They should be symmetrical and aligned. We have to look at the shape, and we have to look at the two opposing points on the 5 mm central circle. Starting with the parameters. Whenever we find the inferior point higher or has a larger number than the superior point, we can accept a difference of less than 1.5. Of course, these numbers are rough, and I'm mentioning such numbers just to make reading the topography and tomography just easy. But of course, there are indices, there are some numbers that will be mentioned in details when I will talk about classification. But now I'm just talking about very quick and very general look at the maps. So back to the difference between the inferior point and the superior point. Whenever we have the inferior minus superior less than 1.5 diopter, then this is normal. When the superior point has a larger number than the inferior point, then the difference should be less than 2.5 diopters. Regarding the pattern or the shape of the pattern, the normal pattern is the symmetric bow tie, SB. When this symmetric bow tie is vertically aligned, it represents with the rule astigmatism because the steep meridian is the vertical one. Whenever the bow tie is horizontally aligned, then it represents an against the rule astigmatism. And when it is obliquely aligned, it represents an oblique astigmatism. There are some abnormal shapes, such as round, oval, superior steep, inferior steep, irregular pattern, symmetric bow tie. So the symmetric bow tie does not mean that the cornea is normal. Some cases of keratoconus come with a symmetric bow tie. Also, we have symmetric bow tie with skewing between or an angulation between the inferior segment and the superior segment. We call this skewed radial axis index, SRAX. So there is a pattern called symmetric bow tie with SRAX. And we have asymmetric bow tie when we have the one of the segments is larger than the other segment, and this might be inferiorly steep, asymmetric bow tie inferiorly steep, or asymmetric bow tie superiorly steep. And sometimes the asymmetric bow tie comes with skewed radial axis also. There is also the butterfly, the claw pattern, and the junctional. And we will see now these patterns in real. We will see on topography. This is the round. This is the oval, superior steep, inferior steep. This is the irregular pattern. This is an abnormal symmetric bow tie. Look at the pattern. It is symmetric. There is no skew, but the numbers are very high. 61 in the 0.7 in the superior part and 58.4 in the inferior part. So it is keratoconus, but with symmetric bow tie. Now this is the skewed radial axis. Whenever we have an angle between the axis of the inferior part and the axis of the superior part of more than, equals, or more than 22 degrees, then this is abnormal, and this is called SRAX. This pattern is symmetric bow tie because both segments are equal in size and numbers, but they are skewed. This is asymmetric bow tie inferiorly steep, asymmetric bow tie superiorly steep. This is asymmetric bow tie with SRAX. The angle here is 25 degrees. This is the butterfly. This is the claw pattern. Now the claw pattern, or the crab claw pattern, is not a hallmark of pellucid marginal degeneration, is not a hallmark of pellucid marginal degeneration, because it can be seen in some cases of keratoconus, and I called this pellucid-like keratoconus. This is the junctional or vertical D. This is the smiling face. This is the vortex pattern. Look at the distribution of the red and blue segments. The red segments represent the steep parts of the cornea, and the blue segments represent the flat parts of the cornea. Whenever the distribution is in a vortex pattern, this is the vortex shape, which is abnormal. So in summary, we have to look at the pattern, at the symmetricity of the two segments, and the angle between the axes of these two segments. The elevation map. There is a similarity between the Earth, where we live on, and our globe, the cornea of our globe. As you see here, these pictures, the diameter of the Earth at the equator is 12,000 kilometers, while the horizontal diameter of the cornea is 12,000 microns. But the difference between these two objects is on Earth, we can measure elevations and depressions, mountains and valleys, according to a reference surface, which is the sea level, while on the cornea, there is no reference surface. So it has been decided to create a reference surface to which the topography of the measured surface of the cornea is related, and those parts which are above the surface will take positive values, and those parts that intersect with the reference surface will take zero values, and those are below the reference surface will take minus values. In addition, these information will be plotted as, or will be color coded. So the higher the level, the hotter the color will be, and vice versa. But what about the reference surface itself? Of course, there are many types of reference surfaces, but the most important two reference surfaces are the toric ellipsoid, as you see here on the left, and the spherical on the right. What is the difference between the toric ellipsoid and the sphere? Or let me ask the question in another way. When we should use the toric ellipsoid to study the cornea, and when shall we use the spherical surface when we want to study the cornea? Now, when I want to highlight the shape of something, I should put this thing among things that are not similar to it. And this is the principle of the best fit sphere. Why? Because the cornea, the shape of the cornea is toric ellipsoid. It is aspheric toric ellipsoid. So whenever I want to highlight the shape of the cornea, I should use something which is not similar to its surface. So I should use the best fit sphere. On the other hand, if I want to measure the details of the cornea, then I should use a shape which is similar. So when I want to see the shape, I have to use the best fit sphere, and when I want to measure the details of the shape, I should use the best fit toric ellipsoid. Now, this is the shape of a normal cornea using the spherical reference surface. We should pay attention to the diameter of this reference body. It should be 8 millimeter as a standard, and the normal shape is the symmetric hourglass pattern. Now, the symmetric hourglass pattern, when it is vertically oriented, it represents with the rule astigmatism. This is, as you see here, this is opposite to what we have just said about the curvature map. Now, why we have the cold colors or the blue colors on the vertical meridian in case of with the rule astigmatism? This is because the vertical meridian in with the rule astigmatism is steeper than the horizontal one. Since it is steeper, it means that it is more curved, and hence it falls below the reference surface and will take the minus values and color coded as cold colors. And vice versa for the horizontal, which is flatter than the vertical, and it falls above the reference surface and takes positive values and color coded with hot colors. Regarding measuring the details, as I said, we have to use the toric ellipsoid with 8 millimeter of diameter also. Now, we have to look at the central 5 millimeter central zone, and we have to know that whenever we have positive values, it means that they are elevations, they are above the reference surface, while the depressions take minus values and they are below the reference surface. And finally, the flat areas take zero values and they are in touch with the reference surface. Now, there are two ways to evaluate the elevations and depressions. I mean to study the parameters, not the shape, the parameters of the elevation maps. The one which is roughly used, and I use it, usually I use it. I look at the central 5 millimeter central zone, and I look at the values. Now, the normal values on the anterior surface within this zone should be less than 12 microns, and for those on the posterior surface should be less than 15 microns. Whenever we have anterior more than 12 microns or posterior more than 15 microns on the best fit toric ellipsoid, this means that these numbers are abnormal. So the normal numbers are below 12 for the anterior and below 15 for the posterior. Now, there is another way presented by Belen Ambrosio. We look at the map with the best fit sphere, not the toric ellipsoid, the sphere. Here, not the shape, the parameters also, but on the best fit sphere. And we look at the number corresponding to the thinnest location. We look at the number on the anterior and posterior elevation maps. Now, this table represents the normal numbers. As you see here, the numbers are different between myopic and hyperopic people. We look at the numbers corresponding to the 3 standard deviation. For the anterior elevation map, the average normal number for myopic patients is 7.7, and for the posterior is 17.7. For the hyperopic people, the anterior number in average is 6.5, and the posterior one is in average is 27.8. Regarding the shape, as I said, the normal shape is the symmetric hourglass. Sometimes this hourglass may have a skew between the axes, but yet there is no definite number that says this skew is normal or abnormal, such that mentioned for the curvature map. Uh, but we have to know that this skew sometimes appears because of misalignment during taking the capture, or sometimes because of high angle kappa. So we have to repeat the capture whenever we see this skew. This is an abnormal pattern. It is the tongue-like extension. It means that this surface is very distorted. These are samples of abnormal shapes, as you see, tongue-like extensions, irregular, symmetric, irregular hourglass patterns, but the most dangerous is the isolated island. The isolated island on the best fit sphere means that there is a protrusion either on the anterior surface or the posterior surface or both. So we have to pay attention to this sign, the isolated island. So in summary, we have to study the pattern of the elevation map using the best fit sphere, and we have to study the parameters of the elevation maps either by using the rough method depending on the best fit toric ellipsoid, or we can use the best fit sphere with the table that has been mentioned. The Pachymetry map. On the Pachymetry map, we have to look at the shape and some parameters. Here also, it's very important to look at the two opposing points on the central 5 millimeter circle. The difference between these 2 points should be less than 30 microns, otherwise it is abnormal. Also, we have to look at the relationship between the thinnest location and the apex of the cornea. We have to look at the location of the thinnest point in relation to the apex of the cornea. Such as in this case, as you see here, there is a horizontal displacement of the thinnest location. Look at the number, the x coordinate of the thinnest location in relation to the pachymetry, the pachy apex, which is the apex of the cornea. We can see there is a horizontal displacement. However, the horizontal displacement is not that risky, such as the vertical displacement, where we call the shape we call it the dome shape, which is an indicator of keratoconus or ectatic corneal disorders. There is another abnormal shape, which is a hallmark of pellucid marginal degeneration on the pachymetry map. This is called the bell shape. It takes a shape of a bell. As you see here, there is an inferior thinning of the cornea, and this shape is a hallmark that differentiates between the pellucid marginal degeneration and the pellucid-like keratoconus, as will be discussed later in details. Finally, there is an abnormal shape which is called the keratoglobus. In keratoglobus, the thinning is generalized, and as you see here, it extends to the periphery of the cornea and the limbus. Thickness profiles. In the pentacam, just in the pentacam, there are two profiles related to thickness. I will not discuss the basic of these profiles because it takes time, but what's important here is to look at the shape of the red curve. The red curve represents the profile of the measured cornea, while the dotted black curves indicate the normal values in population. We have to look at the shape. We have to look at a number called an average, and also we have to look at the zone of 6 millimeter. We will take examples in order to explain this. Whenever we have a quick slope, it means that the red curve leaves its original passage very quickly before the zone of 6 millimeter. This is abnormal. Sometimes this red curve takes an S shape, which is a very indicative sign of early keratoconus or early ectatic corneal disorders, including ectasia, and sometimes we can find it in form frost keratoconus. The flat shape of the red curve indicates very thickened cornea. These thickened corneas can be found in Fuchs dystrophy, cornea guttata, or sometimes corneal edema after some diseases such as post-cataract or intraocular surgeries, corneal decompensation, I mean. Also, this is abnormal. There is a very rare shape called the inverted shape, where the curve takes an upward passage, and this is an indicator of pellucid marginal degeneration. Now, so we have to see the shape of the pachymetry map, the symmetricity, and the shape of the thickness profiles, and we have to look at the average, as I said, the number of the average. Now, the normal number of the average is below 1.2. It should be 1.1 or less. Whenever it is more than 1.2, it means that the cornea is asymmetric, the cornea is distorted, so we have to be careful. In this video, I will stop at the parameters, and the parameters will be discussed in later in the next video.